Good afternoon. It is September 12th and we are 4:30 in the afternoon. I apologize. This is going to be a long video because I'm going to be doing a little explaining as we go for newbies. All right, we have a lot going on our sun, and I want you to pay close attention to all these roping loops that you see, especially the ones that run between sunspots. Because as you see, they tend to pop out and erupt, and those are what causes your CMEs. Okay, what's the difference between a CME and a filament? A filament is a light eruption. It's a snap, a crack, and it doesn't release plasma. It releases light, wind, and a little radiation. CME is when the filaments that are lifting up off the face of the sun release plasma, irradiated particles, as well as wind. Okay, so one moves fast, and it can cause auroras if it's long duration, or it cannot cause aurora, and that's a flare. And it can reach Earth in as little as 8 minutes. A CME can take as long as 36 hours to reach Earth, and it moves slower because it is dense and it has all these different atoms and particles in there that cause auroras. You can have auroras from a flare, you can have auroras from a CME, but flares can also not cause auroras. It's confusing, I know, but for newbies, that's how it works. Now, in our environment over the last 3 days, we have had what we call long duration flares. These do cause auroras. And this afternoon, we started seeing the first of our aurora events happen. We're at a KP5, at a KP6. And we're going to explain why that happens as I go along. But part of that is due to the environment we have with these long duration flares. Now remember, flares move really fast. They're the speed of light. CMEs are like grandma. They move really a lot slower than the flare. Okay, so flares are the teenagers, CMEs are the grandmas. Okay, so let's go down here. We're going to back up to the 10th. The afternoon of the 10th, we get our first CME. We're going to look at that. That is fairly dense. Not really dense, but it's fairly dense. Okay, and it's moving off. And what you got to remember, we're taking a 3D environment and making it flat in a 2D environment. So that's coming off from where my hand is. So it's coming off at a 90-degree angle. So some of that is going to hit us. It's not going to be a direct hit, but some of it will hit us. Now, it is moving really super slow. This is like great-great-grandma. She can barely creep across the floor. That one's great-great-grandma. She's barely moving. Behind her, she's got one moving just twice as fast, and it took off beside about the same trajectory. So that's going to pick up things and move it. It's going to pick up some of those particles and push it a little faster. Well, on that, now we got one coming off this side around it. Yep, that's going to push that a little bit faster right there. But over here in the middle, we still got these super slow particles. Okay, now we got one off on the other side going totally a different direction. Now we got one coming down underneath, and it's moving 3 times as fast. But now we get over here. Well, that's moving that way. That's not going to affect it too much. That's coming around that way. But as you can see, it's starting to make this line right across the bottom. It's starting to march across the bottom. And those are moving way faster. So as you see that happen, I want you to picture you're holding a snow shovel. And that snow shovel is these really fast solar storms, the CMEs. the really fast ones. And you got all these really super slow storms out in front of it that are just particles moseying. They're like great grandma wandering their way across the floor. They don't know where they're going. They're just kind of meandering their way to Earth. And then this teenager comes along and scoops them up really fast with a snow shovel. So picture that snow shovel as it's picking all these radiated particles up and all these electrified particles, and they're building up on the front of this snow shovel, right? And they're getting really super dense, and they're piling up, and when they hit Earth, it's like, oh, wait a minute, we hit a bump, and it's all going to dump off the front of the snow shovel. And if they're the right charge to be opposite of the magnetic charge of Earth, they're going to dump into our poles, right? And we're going to get a really big solar storm because it's super dense and it's a lot all at once. If it's the same polarity, then it'll skate around Earth and go around our magnetic bubble. See? So if it's the same polarity as our pole, it's going to push it away from us. It's going to flow right around us. But if it's the opposite polarity, it's going to dump into us. So this is why we get hits and misses. Any Aurora hunter that's done this any amount of time knows that there's a 75% chance they're wrong. That it's never going to be exactly what they say it's going to be. Because they can't get out there and measure the polarity of the wind coming at Earth. They don't know whether it's positive or negative until it hits the satellite, right? They don't know exactly what trajectory sometimes things are going to take. They're guessing at a lot of this stuff, but the direction that things take, the polarity that the wind is charged at, and the particles are charged at, and the speed things are moving determines whether it's going to be a hit or a miss, or whether it comes sooner or faster. Now, we've got all these, medium-sized, fast solar storms coming, so that's going to speed things up, and it's going to keep us elevated probably through the night. And we get down to this one, and this has all been from 1700 hours, which is 17. Oh, I'm bad at clocks. So this hit at 1700 hours. It was super slow. So it's going to be, I'm going to say it's going to take I'm going to err on a 6-hour difference. Maybe a 7-hour difference. So what we got this afternoon is that first hit. What we're going to get tonight is going to be this hit. We've got a 90-degree angle. This is super, super, super dense. And it's a 90-degree hit. It's aiming off away from us somewhat, but they say it's going to hit us. Let's look at this one. And this one follows 6 hours later. So this one will hit. But again, it's moving super, super slow. So this may not hit till early morning hours, people. This is moving really, really slow. Then we have this one who's moving even slower, but it is another 90-degree angle. It's picking up what... Here was the first blast. Here's the second blast. So it is going to be somewhat of a halo hit. You know, you've got a full halo here that could keep going. But there's... This happened... You've got 6 hour... 1:30... You got 9 hours difference between this and that, so I would say this will come in tomorrow night. But we have super, this is slow, and everything that's following it is slow. But then we have this little guy here. He's perking up here. Yeah, he's not going to do much. But I think this will come in tomorrow night, Wednesday night, and I think this will be the one that gives it the boost. But I think it might be early morning before that catches up. Because this was at 10 o'clock or 10 a.m. That happens at 11 o'clock at night. That's happening at, so you've got 11 hours in between. But these two are moving, these three are moving at 3 times, at least half the speed of the other ones. It's going to be a crapshoot. If it comes in on Wednesday, it's going to be really early morning. But this will be early evening, I think. This will be during the day. That'll probably be early evening. And then we've got a slowpoke coming in here. That's another partial halo hit. So I look for everything as I'm seeing it to continue at being a KP4, 5 or higher. We're not going to get tonight, tomorrow night. But the timing of this is going to be really a crapshoot because you've got so many storms moving in so many different directions at so many different speeds. Whether one will be enough to catch up. If this is moving fast enough to catch up with that, we might get it tomorrow night. If that one can catch up to this one, it might give us a solid, and that being as dense as those both were could push us up to being a solid big one. Just at a guess. But that one would have to catch up and push all this other stuff up. But this is at 400. It's moving over half the speed. It's a possibility. And at least scoop up half the stuff that's coming before it. So there is my short-term predictions. I think we're going to be at a KP5 coming into tonight. I think we'll stay elevated, and then tomorrow night we'll have another peak, maybe late afternoon into evening hours and the overnight hours, and we'll see what it does. Looking at our sun, it is important to remember patterns because patterns in nature are very important. They mean something. Our pattern is things are really active over here. And as soon as they hit this point, they kind of quiet down and stop erupting as much until they reach this point when they're directly facing us. They're quiet. As soon as they've hit this point where they just clicked off just Earth facing, they tend to go crazy again. This sunspot was Earth facing yesterday and completely quiet. And it is gone Oh, now it's back down to a beta class. It was beta gamma earlier. Now it's back down to beta class, but it has produced steady flaring today, and it wasn't doing it yesterday. We've got steady flares coming from it, and it's been very active. 3423 has been the one that's been giving us a lot of activity. It has kind of gotten a little bit smaller, a little less organized, and but it is still giving us big solar flares and CMEs, but it's going to be out of Earth facing reach of Earth here in the next day. So he's not, unless it's a really big flare and it's pushed sideways, it really isn't going to hit us and do much for us unless it's a massive, massive eruption. $34.29 was very active yesterday. It has quieted down, but it is reformulating. And how do I know this? Yesterday it was a beta. Today it is a beta gamma class. It's growing in size. It's reorganizing. I look for this one to be quiet and continue to reorganize till it gets Earth facing. Once it ticks off, then it's going to go crazy. And we're going to, in couple of days here, we're going to see this one create some bigger sunspots that will affect us into next week. $34.30 is growing. It is a beta class. It isn't doing anything right now, but it is growing. $34.31. This one is hitting that quiet zone. Again, it's growing. It's a beta delta. It is changing its shape, changing its formation. It doesn't look much now, but I think once it ticks past Earth facing, it will be a major player because this one has been really, really active. And it is producing some flaring yet. So, and then we have 34.33, which is an alpha class. And I think this one, once it rotates in and has a chance to grow, it will become something of a player. It's just not there yet. It's got room to grow. Discussing our weather right now. As most of you noticed, it's really cloudy and rainy today. This is going to continue through tonight. You're going to have to use your radar. South is going to be better. And with a KP 5 or 6, you should be safe. Down in the thumb of Michigan, mid-range, Minnesota, Wisconsin, you should be able to go to those areas and see something. West Coast Michigan, you should be able to, go down Cadillac, Michigan, along the west coast of Michigan, farther south, find the holes. Use your radar, get in super close, find the hole, and you'll see something. This is fall weather, and the storms in fall are a little bit different. They're squally. There's been many a times that there has been a thunderstorm on East Bay of Traverse, Michigan, and I've gone to West Bay and I've got a hole in the clouds and got an amazing shot of the auroras through that hole in the clouds. Or it's been raining buckets in Traverse City and I went to Frankfurt or Point Betsy and got some of the most amazing pictures I've ever gotten because the clouds just created the most amazing texture within the auroras. Sometimes it's a matter of 2 miles, sometimes it's 30 miles, but driving that distance can make a difference. So, tomorrow, Wednesday, Thursday, into Friday, it's supposed to be clearer skies then. We're going to see another pattern drift in Saturday into Sunday. That is this pattern starting over here. That is supposed to hold the hurricane offshore. And now we're going to get a little science lesson for all of the newbies. We work with something called the electromagnetic universe. And everything has electromagnetic energy. Electromagnetic energy creates our lightning on Earth. Helps create our storms. We have the magnetosphere, which is in a magnetic bubble. We have the Van Allen belt, which is a secondary magnetic field lines on Earth. We have a lot of magnetic and electromagnetic energy on Earth. The sun has the same. And solar storms expel electromagnetic energy. These particles coming across into our atmosphere are electromagnetically charged particles. So when they hit our atmosphere and they drop into our atmosphere, they hit our electromagnetically charged particles and they combine and they excite them. That's where we get the light proton that causes auroras, because the oxygen molecule that's charged and the hydrogen particle that's charged, they combine and it excites them and it creates a light proton. It's still electromagnetic energy. And when all those charged particles happen, it can create more lightning. It can change the strength of storms. If you remember back at Hurricane Ian last year, it was supposed to be a Category 3 storm. Not a big deal, right? Everybody's prepared for a Category 3 and they had it tracked a little farther north. And then overnight, it blew up to a Category 5. And the weathermen didn't see it coming. They didn't know how it happened, why it happened. And it is because our weathermen are handicapped. They do not understand to mix principles. They aren't mixing the space weather with the weather science that they have. Because had they mixed the principles and understood what I'm explaining to you, they would have known that the solar storm that happened the night the hurricane blew up and the auroras were seen as far south as Des Moines, Iowa at a KP7. That means people south of Wisconsin and Michigan were able to walk out, look up, and see the aurora with their eyes. It was a big storm. That's what put all the charged particles in that excited that storm. And I remember Ryan Hall going, "This is the worst hurricane I've ever seen for lightning. This is the most lightning any hurricane's ever had." And I said, yeah, because we've had a solar storm. And all that electromagnetic energy is causing more lightning. Now we have an invest off the coast of Africa that is supposed to be moving in, and it is supposed to be coming in right beside Hurricane Lee as it comes up into here. So here, it's Hurricane Lee is supposed to be here. That invest is supposed to come up here and then just safely go off to sea. Supposed to come up here, bumper off it, and go out to sea. We have a weather pattern that will be pushing over us Saturday into Sunday and pushing that hurricane out to sea. They think, because they say that the water here has been turned up enough by prior hurricanes that the water is cold enough to break the weather, to break the hurricane. There isn't enough warm water to feed it. They say our weather pattern is going to be strong enough to create wind shear that will break the hurricane, shred it. What I haven't heard is any weatherman looking at our solar weather and realizing that we're going to get some massive solar weather here. That we have the potential in the next couple of days of getting the KP7, the KP6, the exact weather that blew up Hurricane Ian. I look for there to be some significant changes in this hurricane. And I look for the potential that this is going to change and take a different track that weathermen are not expecting. My gut is telling me it's going to take a left turn at some point, somewhere they're not expecting it. Don't know where. If you have someone on the East Coast, it would be wise to tell them to be expecting a change. Because as solar scientists, as space weather scientists, we know that it can change. We know it's going to make a difference. If we get a big solar storm, we know that it's going to feed that hurricane. We need to be prepared. So be on top of it. If you have people in harm's way, you'll want to warn them, because weathermen do not, our dysfunctional weather system does not extend to studying space weather with our weather systems yet. We're trying to change that. A lot of our solar scientists know the connection, and they're trying to get that changed so that we can have better predictions. But this is, science is slow to change, and science is isolative. They do not like to mix principles. It's like geology doesn't like to be mixed with solar science, but we know that space weather has an influence on earthquakes, but they don't like to mix the principles. We know that space weather has an impact on weather, but they don't like to mix the principles. It's changing slowly, but it's going to be a while before it changes. All right. I will end this with an apology to all of you for kind of taking a powder this summer. There has been a lot going on. Some of it I'm going to keep private because it doesn't have to do with just me. There's been some family members that have had issues that I have had to help them with. And that is their private business I won't discuss. I will tell you that we have been through a cancer scare with me this summer. And I am safe. It came back clear for right now, but it is something that they are going to monitor. And this would have been cancer scare number 3. So that is kind of why things kind of got shoved off to the side and put aside. And there's just been a tremendous amount of stuff that I've been dealing with this summer. And you'll have to forgive me for taking the time to deal with that. All right, I will leave you there. Happy hunting for all of you that are hunting. South is better than north. So don't go running north. You want to run south right now. You want to stick mid-Michigan, mid-Wisconsin. You're going to have a better shot. If you end up in the UP, you're going to be cooked. So stay to the south. All right. Have fun, everybody.